Hello everyone, this is Dr. Feng Tian from Governor State University. Today we will talk about normal distribution. In this section we will introduce what is normal distribution and why normal distribution is important. Also we will talk a little bit about the properties of normal distribution. So what is normal distribution? First, normal distribution is a continuous variable probability distribution. And this is one of the most important probability distributions. It is important because, first, many variables in reality are approximately normal. Second, this is the result from the central limit theory. So, if you're familiar with central limit theory, you know. The central limit theory basically tells us it doesn't matter what the population distribution is. If the sample size is large enough, then the sampling distribution will always be approximately normal, which means we can use the normal distribution to analyze the sampling output. Actually, this result is the foundation for most of the statistic studies. It doesn't matter it is confidence interval, it is hypothesis test, or ANUVA test. All these things actually are based on the central limit theory and normal distribution. That is why the normal distribution is the most important probability distribution. Normal distribution is also very well studied. The probability density function is bell-shaped and it is symmetric, and the mean, median, and mode of the distribution are all the same. So here are some of the real-life examples of normal distributions. And these are some of the variables from the real life that are either normally distributed or approximately normally distributed. Things like measures of size of living tissue, like the length, height, skin, area, weight, the length of inert appendages, hair, claws, nail, teeth of a biological specimen. Measurement error in physical experiment, the distribution of long-duration river discharge or rainfall, the travel or transportation time, duration of reaction, results from standardized testing like IQ test. All these variables can be approximated by a normal distribution. The normal distribution has the density function as displayed in this slide. Now here, first we need to understand what the probability density function tells us. We all know that for continuous probability distribution, the probability that the variable equals to a certain number is always 0. Then what does the PDF or the probability density function mean? So probability density function for a continuous variable distribution, first it is important because all the probability or the statistic parameters like the mean, variance, standard deviation are calculated based on this probability density function. Second, the physical meaning of a probability density function is the PDF or probability density function gives us a relative likelihood that the variable can be a given value. If a value has a higher probability density function value, it means this value is more likely to occur compared with other values. So that's the physical meaning of a probability density function. Now let's focus on the normal distribution density function here. Well, we look at the right side, which is the detailed formula of the PDF function for normal distribution function. We can see here we have few parameters. We have pi, we have sigma, we have e, we have x, we have mu. Now, among these parameters, two of these parameters are constant. The value e, which is the natural logarithm base, which is 2.71828. Pi is a constant, and the value is 3.14159. Now, the other three are the variables. Mu, which is the population mean, and sigma is the population standard deviation. So basically, these are the two parameters describe the population distribution. And x is the value of the continuous variable, which basically is the one that we use to calculate the corresponding probability density function value. Now, if we look at all these parameters, basically the value mu and sigma, or the population mean and the population standard deviation, will determine how the probability density function looks like. Because E and pi are two constants. Now, let's take a look at the probability density function and see how it looks like. This is the normal distribution curve. Normal distribution curve is usually the normal distribution curve of the probability density function. Now we can see from the chart here, this is a curve, how it looks like. We can see it is bell-shaped and it is symmetric, means the left side and the right side are the same. And the mean, median, and mode are equal. So in the middle is the mean, it is the mean, and it is median and the mode. So for a normal distribution curve, or the PDF curve, the center is determined by the mean, mu. The spread is determined by the standard deviation, sigma. And the range of this random variable, actually, theoretically, it is defined from negative infinity all the way to positive infinity. So this is how the normal distribution curve, or the normal distribution probability density curve, looks like. Now, as we said, well, the curve is determined by the mean and the sigma. The mean determines the center of the curve, and the sigma determines the dispersion of the curve. So if we change the mean, mu, it will shift the curve left or right. If we increase the value of mean, the whole curve will be shifted to the right side. If we decrease the value of mean, the whole curve will be shifted to the left side. But it will not change the shape of the curve. The shape of the curve, or the dispersion, or how the curve is spread, is determined by the value of standard deviation, population standard deviation, sigma. If we increase this value sigma, then the curve will be more flat, means it is more spread out. Otherwise, it will be more concentrated. Let's take a look at a few examples. Now here are three normal distribution curves. We have three curves, and the corresponding population standard deviation, sigma, are the same. All three curves have the same sigma equals 2. The only difference is the mean. The mean changed from -2 to 0 to 3. Now we can see the first, the blue curve here, the mean is -2. So basically the center of this curve is -2. And when we look at the second curve, the red one, it has the same standard deviation. So we can see the curve has exactly the same shape as the first one. But because the mean now is increased from -2 to 0, the whole curve is shifted to the right side by 2 units, where here is the mean, the center of the curve. And when we increase the mean to 3, the whole curve, exactly the same shape, but it will be shifted or moved to the right side by 3 more units, where the 3 is the center of the third curve, the green one. Now we see how the change of mean will shift the curve around. But if we keep the standard deviation the same, then the shape of the curve will be exactly the same. Here are the example of three curves. These three curves have exactly the same mean. That is why you see all these three curves, the center of the curve or the middle of the curve are exactly the same. But what is changed is the standard deviation. The standard deviation determines how the curve is spread out or the shape of the curve. Now the green curve has the smallest standard deviation. The sigma is only 1. You can see it is much more compacted. More values are closer to the center. And the blue curve has the largest standard deviation, sigma equals to 4. Now you see it is much flatter than the other two curves. So the higher the standard deviation, then the curve is more spread out. The whole PDF curve will be more flat than other standard deviation. The normal distribution, as we mentioned, theoretically it is defined over from negative infinity to positive infinity. So the total area under the curve has a probability of 1. Because the curve itself is symmetric, so half of the values or half of the curve is below the mean and half the curve is above the mean. So the probability that a given value is smaller than the mean is 50%. And the same, the probability that a given value is greater than the mean is 50% as well. So this is the property from the symmetric. Well, we mentioned that for as other continuous probability distribution, the probability that a normal distribution variable equals to a certain value is 0. Then we may ask, if that's the case, how do we find out the normal distribution probability? Now we know that is a normal distribution from negative infinity to infinity that includes all the possible values under the curve. The total probability is 1. Now, so how about other probabilities? The probability of a normal distribution is measured by the area under the curve. It is under the curve, so basically it is defined on an area. It is not defined on a given value. So you will never see what is the probability that x equals to a certain value. It is always defined as x is within a range. It can be the probability that x is greater than a and smaller than b. And a and b defines this red area under the curve. And this area will give us the probability that the random variable will fall between these two values. Because the probability that x equals to, or the random variable equals to any given value is 0. So the sign here doesn't matter. It can be x greater or equal to a and smaller or equal to b. But this probability is exactly the same as x is greater than a and x is greater than b. So the edge actually doesn't matter. Well, this is one way to define the normal probability, which is we define an edge. We define a range from a to b. What is the probability that the value is between a and b? Other ways could be what is the probability that x is smaller than a, or what is the probability that x is greater than b. Now, these two are two other ways to define the range, because smaller than a actually means from negative infinity all the way up to a. And greater than b means from b all the way up to positive infinity. So these are the two other ways to find the normal probability from the distribution. So when we look at the normal distribution probability, we will always see one of these three types. Either x is smaller than a given number, or x is greater than a certain number, or x is in between of two numbers. So that will be the way to define the area under the curve, and that will be the way to define the normal probability. So for normal probability, we have such empirical rules. If we take a look at the normal distribution curve, we know that the probability is defined by the area under the curve. If we look at the area from mean minus 1 standard deviation to mean plus 1 standard deviation, so basically that is the center area, but the left side and the right side are both 1 standard deviation from the mean, then this area will include about 68% of all values, which means for a normal probability distribution, 68% of all values will fall within 1 standard deviation away from the mean. So 1 standard deviation away means it can be 1 standard deviation less than the mean or 1 standard deviation above the mean. So that is the first empirical rule. Similarly, if we look at the area or the range that is 2 standard deviation from the mean, which means from mean minus 2 standard deviation here all the way up to mean plus 2 standard deviation, then this area will include about 95% of all variables. And 3 standard deviation will give us a probability of 99.73% of all values. So this is the empirical rule. So if we know the population mean and the population standard deviation, we can easily find out the range that give us 68%, 95%, or 99.7% of probability.